Let us go for the next topic. The next topic that we discuss in the computer organization is the computer performance evolution. So, what do you understand by computer performance evaluation? It is the evaluation of the performance of the computer, how better it perform. So when can we say that your computer is performing better? So it depends on how fast. Okay, most of the time, it is how fast your computer is working, okay, or is computing the operations, uh, or uh, how much power that particular computer, the secondary uh, evaluation can be done based on the space, the cost, the power that is consumed, okay. But
Minimum time of execution.
yeah, minimum time, so that is the speed, okay. So the most important performance for the computer is the time of execution or the speed of execution, okay. So speed of the execution, as you may be aware, that it depends on the system clock, okay. In the digital electronics, we discussed about the sequential circuits, that is the counters, okay. So what is a counter? Counter is a circuit which counts. What it counts? It counts the pulses, okay. Whereas the shift register is the circuit which shifts the uh, bits. Either you can shift left or you can shift right. Uh, so in case of the serial in and serial out, it is shifting of the bits, okay. So all these sequential logic circuits, so if you notice, then they have one of the important input, and that input is the clock, okay. So that particular clock is nothing but the square wave, okay. So usually a quartz crystal is used for generating this particular clock, because this particular clock is to be generated at very high speed. So a crystal is used. Crystal is some device which produces the oscillation, okay. The oscillations, they are like sine wave, you can see here. And this particular sine wave, they are converted from analog to the digital, so that what you get here is what you get is the square wave, that is your signal is either high or it is low. And typically the time of the high period and low period is fixed for each of the clock, okay. So this is the clock that is given to every this is the clock that is given to each of the sequential logic circuit. And that is the computer is also one of the sequential logic circuit, you can say. And it needs a clock. When you talk about the speed of operation of the counters or speed of the operation of the registers, then this clock or the frequency of the clock plays a vital role in the speed of the operation, okay. So you are aware that your computer, or basically your processor, the microprocessor, uh, is having associated with the clock on which it operates. So typically nowadays the Pentium processor that operates, the clock is in gigahertz, okay. So 1.5 gigahertz, 2 gigahertz, 3 gigahertz, like that, okay. So whenever we talk about the specification of the computer, then we talk about what is the typical clock frequency on which it operates. Okay, so if the clock frequency is lower, the speed of operation of that particular basic operation of that particular processor or that computer is lower. If the speed of system clock which is given to it, if it is higher, then then in that case the speed of operation of that particular processor is higher. Okay, so one of the most basic point uh, is that what clock you can what clock you have given to that particular processor, and that determines the speed of operations. Okay, but if you see, you cannot give to increase the speed of operation, you cannot go on increasing the clock speed, because if you go on increasing the clock speed, what happens is that your circuit may not be designed to handle that much clock frequency, and in that case, if you give a clock to a particular circuit for which it is not designed, then the circuit will not be reliable. That means it will not give the intended result, it will not give you the desired result. So that is why many times the circuit specifies what is the maximum clock frequency with which you should give as an input to this particular to a particular circuit. Okay, so with the processor, even the typical frequency is specified. That means if you want the processor to work properly, then this is the frequency you must give to it, and a limit is also given that in no case you should give a clock to this particular processor higher than this particular frequency. If you give that like that, then the operations of that particular processor or operation of that particular digital circuit will not be correct, and that circuit will not be reliable in that case. Okay, uh, it is not only the upper limit for the sequential logic circuit for the clock. Many times there is a lower limit also. That means you should, in no case you should give a frequency which is less than a particular frequency. Okay, so both lower and upper limit exist for the system clock for each of the computer. Okay, so if a computer uses a lower clock frequency, then that is a slower one, you may call it as a slower one, whereas some computer which uses the higher frequency, then that particular higher clock frequency, then that computer you may call it as the faster computer. Okay, so the basic difference, basic performance, or the comparison between the computer you can make is based on this particular system clock. Okay, so what is the system clock that it uses? Okay, the earlier processors, if you compare, if you Google and if you compare the system clock frequency, so earlier, for earlier computers, that particular frequency was used to be in megahertz. Okay, the system clock for those computers processors, they were in megahertz, but nowadays the processors are coming whose frequency is in gigahertz. So these particular processors. Okay, so it is clear that the current days processor, they are faster than the earlier versions, earlier counterparts of those particular processors. Okay, so this is one way that you can evaluate the performance of the computers. But many times it may happen that two or more computers, they have the same system clocks, and in that case you need to go for the different parameters with which you can evaluate the performance of the computer. Okay, so the purpose of evaluating the performance is that you would like to know which computer is better than the other computer, or in a given application which particular computer would be good computer. Okay, so usually that you do when you are purchasing a new mobile or a new computer, then you check for you compare the PCs, computers or laptops based on their performance. Okay, so in that the speed of that particular computer is one of the major uh, the performance. Okay, so one of the important parameter for the computer is how many instructions that particular uh, computer processes in 1 second. Okay, so how many instructions are executed? Okay, so first parameter we have seen, that is the system clock. We can measure, we can evaluate the the uh, evaluate the performance by using the system clock, but that is very basic, you can say, parameter for evaluating or evaluation of the performance of the computer. Okay, the one of the popular measure for the, or you can say the parameter for evaluation of the comparison is the number of instructions that are executed per second. How many instructions? Okay, as you may be aware, what a particular computer does, a computer fetches instructions. Where are the instructions stored? The instructions are stored in the memory. So computer fetches those instructions, and the computer execute that instruction one after another. Okay, so the instructions are stored in the memory, and that group of instructions stored in the memory is called a program. So what a computer does is fetching the instruction and executing those instructions. So this is the basic operation any computer or any processor or a processor is doing. So one of the important parameter which can be specified based on this is how many instructions a particular computer fetches and execute in 1 second. Okay, so this particular parameter is usually called CPI, that is cycles per instruction. So how many cycles are required per instruction? Okay, so it is one at the same, that is earlier in some you can say uh, earlier in some literature it was instructions per second. Okay, so how many instructions are executed per second, but the one more parameter is defined, that is how many cycle per instruction. So it is you can say the reciprocal, these two quantities, they are reciprocal of each other. Okay, cycles means the clock periods, how many clock periods, how many system clocks are required per instruction. Okay, and that particular clock has the fixed frequency, that is in 1 second there are fixed number of cycles, or there are fixed number of clocks. Okay, of the clock frequency. Okay, so CPI is defined as the cycles per instruction. Okay, but what happens is that the number of cycles required per instructions may be different for the different instructions. The architecture of the instructions or the instruction set of a particular processor, it may be such that some instructions may require less amount of time, whereas some instructions may require more amount of time. Okay, so the cycles required or the clocks required, okay, the number of clocks required to execute one instruction, it may be different for it may be different for the different types of instruction. Okay, for example, I will tell that there are certain instructions which come under the arithmetic group. Okay, so that means those instructions are under the arithmetic group and they perform the operation like addition, subtraction, multiplication, or division operations. Okay, some instructions, group of instructions, they may be the logical instructions and they may be performing the operations like the ORing of the bits, ending of the bits. Okay, parallel bits. Okay, so simultaneously it performs these operations parallelly on the group of bits. Okay, there may be data transfer instructions. Okay, So these instructions, they transfer the data from uh, one location to the other location, that is from register to the memory, or from memory to the register, or it may be from IO devices to the registers, that is within the CPU. Usually the registers are always there inside the CPU, or particularly inside the arithmetic and logic unit. Okay, so from where to where the data is transferred, so depending on that, there can be different types of even the data transfer instructions. So all these instructions, they need different time for execution. So here what you can do is that to calculate the overall cycles per instruction, you can calculate the CPI for each type of instruction. For example, CPI I, so it represents the cycles required for instruction type of I. So there may be, let us say, 3 to 4 types of instructions. So there may be CPI 1, CPI 2, CPI 3. So if there are n type of instruction, then you will be having the CPI 1, 2, 3 up to n. Okay, so that is CPI for, you can calculate the CPI for each type of instruction. You can note the CPI for each type of instruction. Then II is the quantity, that is the number of executed instruction of type I for a given program. Okay, so II is the count, that is how many instructions of I type are executed, so that number is the II. Okay, whereas IC is the number. Okay, so it is not specified here. IC is the number, that is the final instruction count. Okay, so you may be having the I1, I2, I3 up to IN. Okay, so I1 is the number of instructions of the type 1. I2 is the number of instructions of type 2. I3 is the number of instructions of type 3. So like this, there are n types of instructions. Okay, so that is the count. I1, I2, I3, I4 is the count. Okay, whereas what is IC? IC is I1 plus I2 plus I3 plus I4 up to IN. Okay, so if there are n types of instructions, so that will be IN. Okay, so if you take the multiplication of the CPI with its count, and if you divide and if you add these products, and if you divide that by the total number of instructions of each of all types, then what you get is the CPI, the overall CPI. That means for that particular computer, the overall CPI can be specified. So which is so with which you will come to know that how much is the average or overall cycles per instruction for that particular processor. Okay, so if a particular processor needs less number of cycle per instruction, then that particular processor you can say is faster than the other processor. Okay, so this is CPI is another parameter which you can use to evaluate the performance of the computer. Okay, I hope you have understood this particular CPI, cycles per instruction, or for a particular processor. Okay, then the from the CPI, or from this, or you can calculate, either you can calculate CPI, or you can directly calculate the time required to execute a particular program. Okay, so you may take some program, and you can calculate the time required for execution of this of that particular program, and that particular time, it can be calculated with the help of this particular formula, that is IC. IC is nothing but the overall the number of instructions, the total number of instructions in that particular program. Okay, then P is the number of processor cycles needed to decode and execute the instruction. Okay, so that P is the number of cycles needed to decode and execute that instruction. That is nothing but it is the the it is the instructions that is equivalent to your CPI. Okay, then M is the number of memory references needed. Okay, so how many memory references are required? So actual executing, so the in the instruction execution, instructions will be executed internally, which may read, decode and execution. The instruction need to be fetched. Okay, so for fetching the instruction from the memory, so how many memory references are needed, and that is multiplied by the k. So k is the ratio of the memory cycle time and the processor cycle time. Okay, so that is the k, and if you multiply this by tau, that is tau is the uh, the the time period for one cycle. So if you multiply by this, then what you get is the overall time, execution time of that particular instruction. Actually, this particular overall execution time can be represented uh, with CPI also. Okay, so I will give that particular formula for in terms of the CPI. Okay. So the performance factor, okay, so what we discussed, uh, they can be put into this particular table for the purpose of discussion for measuring the performance of the system, and what they affect. So the there are various parameters when you are going for a design of a particular computer. When you are manufacturers are going to develop a particular computer, then uh, uh, they go for certain instruction set architecture. Okay, so IC is one of the parameter which determines the instruction set. Okay, so uh, if the instruction set for the computer is different, then it is going to it is going to change this particular IC. Okay, for a particular program, the number of instructions required, it depends on the instruction set. Okay, so the in some processor, the instruction set may be complex, and because of that, the number of instructions required may be less. But in some computers, the instructions set, it may be each of the instruction may be very simple, and though the instructions are very simple, but in that case, the number of instructions required, that is the overall count required, it may be high. Okay, then P is the parameter, that is how many cycles required per, or what is the time required for execution, decoding and execution of the computer. So that depends on the architecture of that particular processor. Okay, so if the architecture of the processor is efficient, simple, then this particular time required is less. Okay, the computer technology that you are using, is the VLSI technology or ultra large scale integration technology. So the computer technology that you are using, so it may affect the count also. It may affect the execution time and the memory references required. Okay, or you may be using the different types of uh, uh, you may be using the different types of algorithms for the purpose of execution of the programs, and how these are are used in a particular computer. So that is going to affect the speed of execution of a particular program. Okay, so IC, M, K, tau, so all these are the parameters which affect the speed of execution of the program. The processor implementation, so the parameter P and tau is going to affect that. Okay, so parameter tau is the clock frequency. So the implementation of that particular processor, if it is going to support high frequencies, that means the tau in that case it will be very low. Okay, so it depends on the processor implementation. Okay, the time required for each operation, so is also if affected because of the implementation of that particular processor. Then whether you are using the cache memory or the hierarchy, how is the memory hierarchy, and whether you are using a cache memory. What is a cache memory? Cache memory is the fastest memory. Okay, so it is the memory which is very close to the CPU and is much faster than your normal memory. How much is the cache memory and how is the memory hierarchy? Because this cache is not present at one level. There are different levels of cache. Okay, so the cache which is very close to the CPU or inside the CPU is the fastest cache. Okay, so there are level 1 cache, level 2 cache, level 3 cache, and like that. Okay, so this is the hierarchy of the memory. So that determines this particular k. Okay, so how many memory accesses are required, how fast those accesses are, and of course what is the speed, at what speed, what is the maximum speed this particular memory support, how that is within how much time, within how much time that particular processor uh, that particular processor is able to fetch the instruction. Okay, so what is the maximum speed allowable by the memory? So these are the various system attributes or the parameters a particular processor computer supports. Okay, uh, then the uh, one of the another measure of the parameter which is again put as a CPI in a different form is the MIPS rate. Okay, what is MIPS? That is millions of instructions per second. Okay, so how many millions of instructions per second are executed by a particular processor is called the MIPS rate. Okay, so what is the MIPS rate of a particular processor? So that can be easily calculated from the CPI. Okay, or it may be it can also be computed from the IC. That is how many instructions are to how many total number of instructions are executed uh, and what is the time in which those instructions are executed. IC is the number of instructions executed. T is the time required for execution of those instructions, and that is divided by 10 to the power 6. So this is how you get the MIPS rate. So this is one way to compute that. Another way is to compute those that particular factor is from the CPI of that particular computer. So it is the f is the clock frequency. So clock frequency of that particular computer divided by CPI. So this here the CPI is the overall CPI into 10 to the power 6. So this is how you can calculate the MIPS rate, that is million instructions per second. So how many million instructions are executed by that particular processor is one of the parameter, commonly used parameter. What is the MIPS rate? Okay, so let us consider one example with which we will calculate the MIPS rate for a particular computer. So the example reads like this: consider the execution of a program which results in the execution of 2 million instructions on 400 megahertz processor. Okay, so here 2 million instructions, total 2 million instructions are executed. So this is the IC given, that is 2 into 10 to the power 6 is the IC, total number of instructions executed, total number of instructions in a particular program. Okay, whereas 400 megahertz, so this is the frequency on which that particular processor is executing. So clock frequency or system frequency. So your F is 400 into 10 to the power 6. Okay, that is hertz. Okay, or cycles per second. The program consists of four major types of instructions. Okay, so there are four types of instructions. So we consider there the so here it will be I1, I2, I3, and I3. So I1 will be the number of instructions of uh, first type I2 will be the number of instructions of second type. So like that I1, I2, I3 and I4. The instruction mix and the CPI for each instruction type are given below based on the result of a program trace experiment. Okay. So there are four instruction types. The first type is arithmetic and logic instruction. Second type is load store with cache hit. Uh, then next is the branch, and the final one is the memory with cache miss. Okay. So the CPI for the first type of instruction is 1. CPI for the second type of instruction is 2. The CPI for the third is 4. That means for executing arithmetic and logic instruction, only one cycle is required, one clock cycle is required. For executing the load or store instruction, two clock cycles are required. Okay. For executing branching instruction, four cycles are required, and for executing the instructions with the memory reference and cache miss, so eight cycles are required. Okay. So the mix of this particular instruction is, that is, arithmetic instructions are 60%, load store are 18%, branch are 12%, and memory references with cache miss are 10%. Total 2 million instructions are there. So this is the percentage of the instructions in that. Okay. So I1 type are 60% of 2 million. Okay. So we calculate that where is, okay, that slide is not there. So uh, you need to, let me see whether that slide has moved ahead. No. The problem is given, but the answer to this particular problem, I thought that I put it on the slide, but it is not there. But I will tell you how it is to be done. So we shall be using this particular formula. That is CPI. The overall CPI can be calculated by this particular formula. That is CPI 1, CPI 2, CPI 3, and CPI 4 is given to us. I1, I2, I3, I4 can be calculated. IC is 2 million, and we need to calculate I1, I2, I3, and I4. The percentage is given. I1 is 60%. Okay. I2 is 18%, I3 is 12%, and I4 is 10%. Okay, so from this we can calculate I1, I2, I3, I4. The CPI1, CPI2, CPI3, and CPI4 is given here, and IC we know. So from this we can calculate the overall CPI. Okay, and once we calculate the overall CPI, we can even calculate the total time required for execution of this particular program. Okay, and we can see the uh, performance of this particular computer on which this particular program is executed. Okay, so already few minutes I have taken more, so we shall stop here, and we shall continue with more, you can say, parameters for execution in the next class. Okay, so you can proceed for the next class or test, whatever you may be having. Okay, so you may leave the session now. I hope all of you have marked your attendance. If not, still 1 minute, up to 9 I scheduled it, you can mark it. Okay, bye, good day.
Thank you, sir. Have a nice day.
Yes, okay. Yes, all of you leave the session so that the recording will stop automatically. Even if one member is there in the session, it will keep on recording. Yes, Nikita, Zahir, Pranali, Shital, Shreyas, Are you there? Pranali, leave the session. Sridhar, leave the session. Shreyas, not there.